In this video, I'm going to show you how we can find the integral of functions using the substitution method. The focus in this video is on the integrals that after the substitution, we get to this formula. Integral of du over 1 plus u squared is tangent inverse of u plus c. This is one of the most important integral of formulas, but the problem is that many students ignore this important formula and they think that maybe this is not important formula, but this is one of the most important integral formulas. And in these examples, we will see how much this formula is important. There is a more general form for this formula, and that's this formula. Integral of du over a to the 2 plus u to the 2 is 1 over a tangent inverse of u over a plus c. The difference is that in this normal formula, we have only 1 here, just 1. But in this general form, here can be any number squared. It doesn't need to be necessarily 1. It can be 4, 2, 3, and so on. So, if we have any number squared plus u to the 2, then the answer of the integral is 1 over a, 1 over, not exactly this number here, a square root of this number, tangent inverse of u over a plus c. So, before we start our examples, let me write down this formula for you here, because we need this. Integral of du over a to the 2 plus u to the 2 is 1 over a tangent inverse of u over a plus c. For example, integral of dx over 9 plus x2 is 1/3 tangent inverse of x over 3 plus c. Don't make this mistake that you think that, okay, 9 goes here. No. A to the 2 is 9, so a is 3. So 1/3 tangent inverse of x over 3 plus c. Another example. Suppose we want to find integral of d theta over 2 plus theta squared. The answer would be 1 over a to the 2 is 2. So what is a that I have to substitute in for my formula? A to the 2 is 2, so a is a square root of 2 plus minus a square root of 2, what we consider a to be positive. So 1 over radical 2 tangent inverse of theta over radical 2 plus c. And a final example. What is integral of dx, for example, over x to the 2 plus 100? This is exactly based on that formula. U to the 2 is x to the 2, and a to the 2 is 100, which is 10 to the 2. So the answer of this integral would be 1 over a, 1 over 10. Attention, x is variable here. A is a constant. So 1 over 10 tangent inverse of x over 10 plus c. Now that we are familiar with this formula here, let's back to our question. What is integral of x over 1 plus x to the 4 dx? When I look at this example, the first thing that maybe we check is that, let's see if we choose all of the denominator as u works or not. Because in substitution, usually we choose the denominator as u. But if you choose u to be x to the 4 plus 1 or 1 plus x to the 4, the derivative of u would be 4x to the 3 dx. Don't worry for 4. 4 is a number. Focus on x to the 3. Do you have x to the 3 in numerator? You know, you have just x. So this shows that this substitution doesn't work. And this means that we have to think to another thing. So denominator is not u. And of course, u cannot be numerator because in numerator you have only x. But when I look at this example, this expression reminds me things like this. This is especially like 1 plus x to the 2, not 9 plus x to the 2, but 1 plus x to the 2. But it's x to the 4. So what was the problem that this cannot be u? Because the derivative of this is not in numerator. But attention, I know this is tricky, but you have to learn these techniques. But attention, if you write the denominator in the form of x to the 2, then the derivative of this, not all of this, only this bracket, is exactly in the top. Not exactly, but almost. So here, first we rewrite this expression in the denominator in this form. And the reason that we do this is that we want to convert this to this formula here. Then we say u is x to the 2. And then du is 2x dx. And we solve this for dx. dx would be du over 2x. Now let's do the substitution. I need my space here, so let me erase these examples from here. So we do the substitution. This equals to integral x over 1 plus u to the 2. Attention, x2 is u, so x2 to the 2 would be u to the 2. And dx, for dx we use this. dx is du over 2x. X with x cancels, and then we have du over 1 plus u to the 2. What happened to these 2 in the denominator? Move it to the outside of the integral and write it as 1/2. This is better for finding the integral. Now look at this. We can use this formula. And a in this case is 1. So 1 over 1. So the answer of this integral is, don't forget the 1/2 that is outside. 1/2 times 1 over 1. We don't need to really write 1 over 1. Tangent inverse of u over 1. So u over 1, which is u, plus c. So the answer is 1/2 tangent inverse of u, but u originally is x2. So tangent inverse of x2 plus c. And this is the answer of the integral. So this is tangent inverse or arctangent. So the answer of the integral of this expression is 1/2 arctangent of x to the 2 plus c. Let's move to the next example. What is the integral of cosine x over 9 plus sine to the 2x? Again, similar to the previous question, if you try to choose this as u, you would see that the derivative is not in numerator, so this doesn't work. And because I can see 9 as 3 to the 2, so first I'm saying, okay, let me rewrite this as cosine x over 3 to the 2 plus sine of x all to the 2 dx. Then I am going to say, okay, it seems that if I choose u to sine of x, then du would be exactly cosine x, which I have in numerator, so this means that this substitution is going to work. Now let's do the substitution. So we have cosine x over 3 to the 2 plus u to the 2. dx is du over cosine x. Cosine with cosine cancels. Then we have du over 3 to the 2 plus u to the 2. If you remember the formula, the answer would be 1/3 tangent inverse of u over 3 plus c. So the final answer is 1/3 tangent inverse of u. Substitute back. U is this. So sine x, tangent inverse of sine x all over 3 plus c. And this is the answer of the integral. Now look at this example. What is integral of e to the x over e to the 2x plus 5? Similar to the previous questions, if we choose this u, the derivative of this is not this, so we have to think differently. So we say This seems a little similar to the formula that we have in our head. If you remember, we know this formula, du over u2 plus a2 or a2 plus u2, doesn't matter the order. This reminds me a little this. I know it's not completely similar, but it's almost. So we would say, okay, let's write this as e to the x. Just we try, we don't know it works or not. Over e to the x all to the 2 plus radical 5 to the 2. Then I'm going to say, okay, u is e to the x. This is my u. Du would be e to the x dx. And attention, exactly we have e to the x in numerator. And don't forget dx is here. From this relation, dx is du over e to the x. Now we are ready for the substitution. So we have integral of e to the x over u to the 2 plus radical 5 to the 2. If you like, you can replace this with u. It's up to you. But it's better to leave it as e to the x because that e to the x is going to be cancelled with dx at the end. So you don't need to really replace it with anything. For dx, which we have here, we have this expression du over e to the x. And this e to the x with that e to the x cancels, so we have du over u to the 2 plus radical 5 to the 2, which I prefer to write it as radical 5 to the 2 plus u to the 2. And this exactly fits with the formula that we have. This is going to be 1 over radical 5 tangent inverse or arctangent of u over radical 5 plus c. What was u originally? 1 over radical 5 tangent inverse of e to the x over radical 5 plus c. I hope by watching this video, now you understand better why this formula is very important. And now you are not going to ignore it, because many integrals can be solved with this formula, with substitution or directly. I hope you enjoyed this video. If you like this video, please subscribe in my channel. Thank you for watching.